Hi there, this is Estelle Trengove. This is solution for question 2 of the practice test for 2020. So this example was a nodal analysis. And remember, for nodal analysis, we always start with Kirchhoff's current law, and then we express the currents in terms of the node voltages, and then we get some equations for those node voltages. And remember, what we want to do is we want to find out all the unknown quantities in a circuit, solving the least number of equations, and we achieve that by solving for the node voltages. So in this circuit, the node voltages are VA, VB, and VC. And if you look at the circuit, you can see immediately that VA is equal to 20 volts. And that's because the only thing that's connected between ground or our zero reference voltage is that 20 volt source. And so we know that the voltage between ground and VA is 20 volts. So VA is at the higher end of the voltage source, and the zero reference node is at the lower end of the voltage source. So we know that VA is equal to 20 volts. Now we write down the Kirchhoff's current law equation. So by Kirchhoff's current law at node VB, and we can see that at VB is over here. We've got I1 flowing into it, I3 flowing into it, and I2 flowing out of it. And remember that Kirchhoff's current law tells us that the current flowing into a node is equal to the current flowing out of the node. So we know that I1 plus I3 is equal to I2. And now if we express I1 in terms of the node voltages, we can see I1, it flows from the higher voltage to the lower voltage. So VA is the higher voltage, VB is the lower voltage. The current is flowing as in the way that we've defined it. So obviously, if it turns out that I1 is a negative quantity, it means that the current is actually flowing in the opposite direction. But for now, we've defined it in this direction, flowing from VA to VB. And so if we use Ohm's law, we know that current is voltage divided by resistance. So we can write write I1 as VA minus VB divided by 80 ohms. And we do the same for I3. So we see it's flowing from the higher voltage to the lower voltage through the 40 ohm resistor. So we can write that as VC minus VB divided by 40. And that's equal to I2, which is flowing down here from VB to the 0 volt reference node through the 20 ohm resistor. And so we can write that as VB minus 0 divided by 20. And the rest is just maths. So we multiply that out by 80, and then we get, remember that we get VA minus VB plus 2VC minus 2VB, and that's equal to 4VB. But remember that since VA is equal to 20 volts, we can write this as 20 volts minus, so that's minus VB minus 2VB, so it's minus 3VB plus 2VC equals 4VB. And if we put all the like terms together, then we find that this is 20 volts is equal to 7VB minus 2VC. And that's the first equation that we need to solve for all the unknowns in the circuit. Now we're going to do the same at node VC. So at VC, by Kirchhoff's current law, we see that we have 500 milliamps flowing into node VC. We've got I5 flowing into VC, and then we've got I3 and I4 flowing out of VC. So at VC, by Kirchhoff's current law, we see that flowing in, we've got the 500 milliamps plus I5, and flowing out, we've got I3 plus I4. And so again, if we write that using Ohm's law in terms of the node voltages, we get 500 milliamps plus VA minus VC over 160, and that's equal to VC minus VB over 40 plus VC minus 0 over 20. And so we're going to multiply by 160, and that gives us 80 plus VA minus VC is equal to 4VC minus 4VB plus 8VC. And remember that VA is equal to 20 volts, so we can write this equation as 80 plus 20 is equal to 5 VC minus 4 VB plus 8 VC, and therefore minus 4 VB plus 13 VC is equal to 100. And that is the second equation that you need in order to solve for all the unknown voltages in the circuit. And if we write that in matrix form, I'm going to just squeeze it in over here. The matrix would look like this. We're going to have 7 minus 2 minus 4, 13 times VB, VC, and that's equal to 20 and 100. And that's everything on this recording.